Welcome back. So we're doing lesson 4. So we're doing trickier trigonometric equations here. Just a little refresher, because we are going to have to do factoring in this one. So we're going to solve these by factoring. Now, so that might give us more than one solution, or 4 solutions, 5 solutions, 6 solutions, or no solutions. It depends on how that works out. Just do a little refresher. Can you factor these quadratics, or not even quadratics, like the first one's not a quadratic? Can you just factor out the GCF? Pause the video, give it a go. Okay, so hopefully you did that. So what we're going to do is we are going to factor out the GCF. So this one's pretty easy. And, well, I said solve as well. So we're actually going to solve this. So it looks like x would have to be 1 to make this work. That was a pretty easy one. I put a 1 back in the original equation. 3 minus 3 is 0. The next one here, you're going to factor out an x as well. So I'm going to factor out a 2 and an x. Now that's behind 2x minus 3. And then you look at that and say, oh, x could be 0 or 3 over 2 to make this thing equal to 0. Right? Just solving quadratics, that's what we usually do. This one's a difference of squares. So remember, when difference of squares, you get whatever the square root of 25 is. That's 5 and 5, and then x squared is x times x. Then 1 times 1 gets us 1, but we need a negative 1. So one of these has to be negative, one has to be positive. So that's the difference of squares because of the minus sign, right? So I'm going to write that at the top here. Fixed difference of squares. Cool. What would make this equal to 0 would be those 2. So remember, I'm just shortcutting this because I could see in my mind, if those were equal to 0, I would add 1, divide by 5, or subtract 1, divide by 5. All right, but you could just write them out if you need to. These are trinomials now, so you follow the procedure. What multiplies out to negative 30 and adds to negative 7. Sorry about that. So it multiplies to negative 30, adds to negative 7. I'll just go through that really quickly here. Let's see. Divide by 5. Nope. Divide by 2. No. Divide by 3. 3 would work. 3 and 10. X times x gets us that. We need a negative 7, so the 10 has to be the negative because it's a negative number. So the bigger number has to be negative. The other has to be positive. Okay. What would make this equal to 0? 10 and negative 3. This one here, you would want to try to factor with the GCF to start off with, make your life easier. But the middle term there is a 1, so I can't factor a 2 or a 6 or anything out of this. So here I'm looking for numbers that multiply out to negative 6 times 12, 72, and would add to, okay, go right again, and add to positive 1. 72 divided by, what's a good number for that? 9? 9 and 8. 9 and 8. Okay, so I was just randomly punching numbers in my calculator there. So I'm just going to factor this using the 9s and 8. So 9 and 8. 9 has to be positive, 8 has to be negative. And I'm going to do it this way, where I put my numbers in, I leave the 6 alone, but then I reduce it down. So I can see the first term here, I could divide, or the first 2 terms, I could divide by 3. So 2x plus 3. And I can divide these both by 2. So 3x minus 4. There we go. So x would be negative 3 over 2 and 4 over 3. But you could factor that however you want. But just remember, try to be quick about factoring. Yeah, be quick. This, I don't know what all, this is just a big blurb here. Don't worry about this. This is kind of the steps of what we did before. Let's try to solve some of these. Okay. So sometimes if you have just a single trigonometric ratio, you notice in this whole thing, there's only one tan theta. The best thing to do is just try to solve for tan theta. Get it by itself. All right. If you have more than one sign in there, like the second question here is a sine squared and a sine, then you can't really solve for sine. You can't get it by itself. So you'd make it equal to 0. You'd factor it if you can. We'll talk about what the sine squared is, what that means in a bit. So this one here, I'm going to minus over the 4 to start off with. Then I'm going to divide the 4 root 3 over to the other side, reduce that down. Negative 1 over root 3. Hey, I've seen that before. Then, because we're dealing with this in degrees on a full circle, I want to find my reference angle. Like 30 degrees, because we've done this before. So go tan inverse 1 over root 3, ignoring your negative. Ends up being 30 degrees. Where is tan negative? Because that is important for this question, though. You ignore it for the reference angle. You still need to determine which quadrants you're in. Add 2 coffee. So we're in not the first quadrant and not the second quadrant. But this, oh, sorry, third quadrant. But we're in the second and fourth quadrant. So theta are those 2 standard position angles in one circle, right, from 0 to 360. So I'm going to have these 2 answers of 150 and 330. Right? So there, that was we're in the second quadrant, so you go 180 minus the reference angle, and you're in the fourth quadrant, so you go 360 minus the reference angle. We get 2 answers. And then you can verify them by putting them back into the original equation up here to see if it doesn't equal 0. That's up to you to decide. I'm not going to do that. So just take for granted it works. Now, if you see sine squared theta, the reason they write this way, this is the same as saying sine theta all squared. Now, the reason they put the 2 here rather than out on the outside like this is to avoid using parentheses. So we don't like writing parentheses all the time. Also, to avoid confusion, because if I forget to write the parentheses, I might write this instead. These are not equal to each other. I might write here instead where it looks like the theta is being squared. And some people might think that that means this. And they would be correct. Like they would square the theta and they take the sine of whatever they squared. So because sine theta squared, that's different than sine squared theta. Right? This one's there. Now, sine squared theta just means sine theta. Find sine theta, then square the answer. Don't square theta first and then find the sine. Right? So these are not equal. So these are not equal to each other, the left and the right side. So when you see this is the same as saying whatever sine theta is, you're going to square it. Now, what we're going to do to solve this kind of question is we're going to put a little let statement here. I was going to say a let statement. I'm going to make let x equal sine theta. Now, we did something similar to this when we did factoring in Math 20 and Math 10, where we kind of replaced something inside there and then we factored it and then we put it back where it was, like here. So if I replace sine theta with x, this first term becomes x squared. The next term becomes sine, or 3x, or negative 3x. Right? So I just replaced it. Now what I'm going to do is I'm going to solve this equation for x. So I'm going to factor the x out. Okay. Then say, okay, what would make this equal to 0? X would have to be 0, and it would have to be 3. Then what I'm going to do is I'm going to replace this x, because I said x was sine theta. So up here I said x had to be sine theta. So I'm going to replace this x that I have down here with sine theta again. So I'm going to go back to what it was before. So it's going to go sine theta is equal to 0 or 3. So I'm going to split that apart. I'm going to say sine theta is equal to 0, sine theta is equal to 3, and then I'm going to solve both those pieces. Okay? Just independently of each other. So sine 0, let's do that one first. Sine 0. So where is sine 0? So I'm going to, oops, not sine. Yeah, so what was that writing? Sine theta is equal to 0. where is sine theta is equal to 0? So let's just let's go sine inverse 0 first. Okay, I get 0 degrees. It says theta ref is 0 degrees. Okay, so let's find out where sine. So remember, this is even my y value. So where's my y value on my circle? So this is a quadrantal angle. 0 degrees is quadrantal. So where is y equal to 0? Y is equal to 0 here on the x-axis and here on the y-axis. So it's in those two quadrants. So I have this angle and this angle. I think I'm going to really draw it because it's on the x-axis, so the reference angle is 0. So I have two angles, 0 degrees and 180. Okay, I'm going to double check that. Sine 0, 0. Sine 180, 0. Cool. The next one I'm going to do, so I'm going to go sine theta is equal to 3. And what I know about this doesn't work. Undefined, error, whatever. There's no solutions this side. Right? So remember, our sine ratio, cos ratios, they cannot be greater than 1. Tan ratio can be whatever it wants to be. Right? But the sine and the cos ratios have to be less than 1 because the hypotenuse has to be larger than the opposite. So mathematically, that ratio always has to be less than 1. Or 1. It could be 1 as well. So there's no solution to this side, so I really only have one answer. Or two answers, I guess, 0 and 180. You'd go back and you'd verify to see if those work. And also you'd go back and say, oh, this has to be in radians. So maybe I should change these to radians. There you go, 0 and pi. 0 rads and pi. Yeah, pretty good, pretty easy. They just all kind of follow the same pattern from now on, right? There's some interval notation stuff down here. We'll deal with that later. So I would replace it, factor it, and then put it back, and then solve the question. So here I'm going to say let x equal cos theta. Like over here, I do the same thing. Let x equal cos theta. Okay, so this ends up being 4x squared minus 1. Oh, this is an x squared, so I could just solve for, I could have just left it alone too, and just solve for cos, because there's only one single cos here. Add the 1 over, divide by 4, take the square root. Ooh. Okay, so we made, so we took the square root, so we're going to take the square root of both sides here. So the square root of a quarter, I'll write it down, is a half. You square at the top, you square at the bottom. But because you took the square root, there are two answers, positive and negative. So this is positive and negative a half. So I have two x's I have to solve for, and I'm just going to replace the x's back. So I got cos theta is equal to positive a half, and I have cos theta is equal to negative a half. So I'm going to have to solve both of these. I can actually solve them both at the exact same time, because the reference angle for both of these are exactly the same. All right, so I can go ref cos inverse 1/2, and I get 60 degrees. Then I would draw this out and say, okay, where is cos positive? Well, it's positive in this first quadrant, so 60 degrees there. It is positive in the fourth quadrant, so that's where they're positive. But I can also say, okay, where are they negative? Because the second question says, oh, they're going to be negative half. So they're also negative in the second quadrant and the third quadrant. So I have these 4 different solutions. I'm looking at the whole circle from 0 to 360 here. So I want to find all of these standard position angles going all the way around. So there's going to be 4 answers here. They all give me the right answers I need here. "60 degrees, that's the first quadrant. 120 is the second quadrant, so 180 minus 60. 180 plus 60, 240, and then 360 minus 60, 300. There you go. Again, I like to solve everything in degrees. And if you have to change it to radians, like this next one here, you're going to have to change it to radians eventually. I would do that after the fact. Okay, so this one here ends up being 2x squared plus 7x minus 4 after I replace all the cos thetas with an x. I'm going to factor this out. There's no GCF here, so we're going to look at what multiplies out to. Negative 8. So you multiply the leading coefficient with the constant term, and which adds to 7. So my two numbers here are going to be probably 8 and 1. 8 and 1. It's got to add to a positive number, so the 8's positive because it's a bigger number. And I'm going to write that out. I'm going to reduce these down. Lots of different ways to factor, but this is the way I do it. This is why I do it now. I used to do it differently otherwise, because I was taught other ways too. Then we're going to rearrange this and say what makes this equal to 0. So negative 4 is going to make this equal to 0. And a half is going to make this equal to 0. And I already realized the negative 4 is not going to work because that is larger than 1. Even if it's negative, it doesn't matter, because you're going to take the sine inverse of that positive number, or in this case, the cos. All right, sorry about that. I'm doing these during my office hours, so every once in a while I have to pause the video, talk to some kid. So what am I doing right now? Oh yeah, we are solving for x. So like I was saying, if I try to take the sine inverse of 4, it's not going to work because, or sorry, in this case, cos inverse, because this is cos theta is equal to negative 4, and cos theta is equal to a half. Oops, sorry, half. So this side's not going to work because I can't solve for theta, so there's no solutions on this one. Actually, sometimes you may have no solutions at all, but in this case, I can solve for cos a half. Like we already did that. Cos a half. The reference angle is cos inverse of a half, which is 60 degrees again. It's positive in the first quadrant and the fourth quadrant. We add sugar to coffee, so the A and the C quadrants. These are both 60 degrees. So therefore, theta is 60 degrees and 300 degrees. Oh, but I also don't want to be in degrees. As mentioned at the beginning of the question there, I want this to be in rads. So this would be pi over 3. And I know this one's going to be over 3. I just can't remember exactly what it is. So I'm going to get my calculator. 300 divided by 180. Math. Enter, enter. 5 over 3. Put the pi back in there. There you go. Awesome. So that's how you do those kind of questions. The next few here, just refreshing interval notation. If you see round bracket, that means not equal to, square bracket means equal to. So you might see that a few times in questions where they talk about. They might give you interval notation like this, these two questions down here. So I'm going to skip past this part. I'm just going to fill it in right now. Okay, so there's the solutions to those ones. You can pause the video and look at those. I'm going to go back up here. So we're going to solve these questions very similar to what we did before. Actually, I want you to try to solve these and come back. And there's more questions down here. How do you solve these as well? Yeah, so I want you to try to solve these questions. Pause the video, try them out. And we'll see you in the next video, actually, just get the solutions to these. I think this video is getting a bit long. See you then. Bye.